A paper cut looks tiny. Underneath it, your body launches a 4-stage emergency construction project before you can even find a bandage. In the next few minutes, you will watch the whole crew clock in. First, stop the leak. Then clean the site. Then rebuild the missing layers. Finally, strengthen and reorganize the repair. These are not 4 tidy boxes on a calendar. They overlap like a relay race where everyone starts jogging early. The first surprise is that your body does not begin by making new skin. It builds a quick temporary bridge from blood components because a construction crew cannot work while the floor is still disappearing. Your skin is a layered barrier. A cut breaks it and can nick tiny blood vessels beneath. The instant that barrier opens, exposed tissue and blood chemistry announce, this spot needs a fast, local fix. Small vessels near the injury can constrict briefly, reducing local blood flow. It is a quick squeeze, not a magical seal. Think of pinching a garden hose while you get your thumb over the leak. Platelets are small blood components that become sticky and change shape after meeting exposed material at the break. They gather, signal to one another, and make the first crowded patch across the gap. Clotting reactions turn a dissolved protein called fibrinogen into fibrin threads. Those threads weave through the platelet patch like a net around loose balls, making a stronger temporary plug that slows bleeding. That clot is more than a cork. It is a temporary matrix, a rough work surface that later cells can grab, cross, and replace. Your body has improvised scaffolding before it has a permanent wall. Next comes inflammation. The word sounds like trouble, but early on it is a controlled delivery system. Vessels become more permeable and immune cells get a route out of the bloodstream into the wound. Neutrophils are among the early arrivals. They help deal with microbes and damage debris. They are not tiny superheroes with capes. They are more like a very hurried cleaning crew that came straight from another emergency. Macrophages arrive and do more than clean. They swallow debris, coordinate signals, and help shift the wound toward rebuilding. The same site that looked like a mess now starts receiving instructions, materials, and a new plan. Redness, warmth, swelling, and soreness can come from this busy local response. More fluid and cells are moving through the area. Early inflammation is not automatically infection. It is part of the schedule when it stays controlled. But this is not a game of guessing from a video. Spreading redness, worsening pain, pus-like drainage, fever, persistent bleeding, numbness, or a deep wound deserve prompt medical attention. That is a safety boundary, not an optional side quest. For repair to continue, inflammation has to change gears. Cleanup cells and their signals help recruit builders. It is the moment a messy renovation stops being demolition and starts becoming a plan you can actually live in. Fibroblasts are key builders in the next phase. They move into the temporary matrix and lay down components of new extracellular support, including collagen. Imagine weavers stretching fresh ropes across a washed-out footbridge. New capillaries grow into the repairing tissue. That process, angiogenesis, helps supply a busy area that needs oxygen and nutrients. It is why healing tissue can look pink or red. It has a lot of new traffic. That mix of new vessels, cells, and support matrix is called granulation tissue. The name sounds crunchy, but it is simply a temporary living bridge. It fills the gap while the surface is still being rebuilt above it. Meanwhile, keratinocytes at the skin edges migrate across the wound. They do not wait politely until every deeper task is done. They crawl over the provisional surface, trying to restore the outside barrier as soon as they can. So the surface can close while deeper tissue is still changing. That is the second big surprise. A wound may look better from above long before the inside has finished its rebuild, like fresh paint on a room still full of ladders. Some fibroblasts take on a contractile role and are called myofibroblasts. They help pull wound edges inward. This contraction is especially useful when there is a larger gap to close because less open space means less rebuilding work. A shallow, small cut and a wider wound do not give the crew the same workload. More missing tissue can mean more filling, more contraction, and more scar. Biology is not choosing favorites. It is solving a different engineering problem. A scab is dried material on the surface. It can protect the outside from bumps and dirt, but it is not the whole repair. Under it, cells are still moving, vessels are changing, and collagen is being laid down. Picking or repeatedly rubbing a fragile surface can disrupt it before the barrier is ready. Think of unzipping a coat while someone is still sewing the lining. The body can respond again, but you have made the job less direct. Once the gap is closed, the job is still not over. Remodeling can continue for months. The early repair was fast and useful. Now the body gradually reorganizes that material for a more durable result. Early collagen is not the final arrangement. Over time, collagen is broken down, replaced, and aligned. Picture a temporary tangle of rope becoming a more ordered braid that can handle a steadier pull without falling apart. A healed area gains strength over time, but repaired skin does not simply rewind to factory settings. It can remain different from uninjured skin. Your body is brilliant at repair, not a time machine with an undo button. A scar can look and feel different because the repaired collagen architecture is different, and some original structures may not return in the same arrangement. The goal was a reliable patch, not a perfect photocopy of every detail. New vessels are useful while the site is busy. As remodeling continues, that excess vascular traffic can decrease, and a bright pink or red mark may gradually fade. Again, the timeline varies with the wound and the person. The 4 phases overlap, and their pace is not identical for every injury or every person. A healing timeline is more like weather fronts crossing than train cars arriving one after another on a perfectly printed schedule. Blood flow, diabetes, smoking, nutrition, certain medicines, infection, age, and the wound itself can affect healing. That is why a slow or changing wound is worth discussing with a qualified clinician instead of trying to diagnose it from vibes. The body is balancing several goals at once. Stop bleeding, control contamination, rebuild tissue, avoid an overgrown scar, and get you moving again. It is like closing a bridge during rush hour while trying not to rebuild the entire city. For a minor cut, basic first aid begins with clean hands and rinsing the wound with clean running water. The point is simple: reduce dirt and contamination so the repair crew is not handed an extra mess. For a small wound, a clean covering can help protect the area from dirt and rubbing. Change it when it becomes wet or dirty. This is deliberately boring advice, which is often the kind that saves you from the least interesting sequel. Get professional help for severe or persistent bleeding, a deep or large wound, loss of feeling or function, a bite, a puncture, an embedded object, or signs of infection. The safe move is assessment, not bravado. For dirty or major wounds, tetanus protection can depend on the wound and your vaccination history. A clinician can tell you what applies to you. A rusty object is not cursed. It is simply not a great place to gamble with biology. Now replay the tiny cut. Vessels squeeze. Platelets and fibrin make a bridge. Immune cells clean and coordinate. New vessels, fibroblasts, and skin cells rebuild. Then collagen slowly reorganizes the patch. 4 crews, 1 continuous repair. The first job is speed. Stop the leak. The second is safety. Clean the site. The third is construction. Fill and cover the gap. The last is patience. Strengthen the repair after it already looks done. A scar is not your body giving up. It is the evidence of a compromise that kept a barrier intact and tissue working. It may not match the old material perfectly, but a repaired bridge can still carry you home. One last safety note. This is an explainer about normal healing, not personal medical diagnosis. If a wound worries you, changes for the worse, or has any red flags, get advice from a healthcare professional promptly. So when that tiny paper cut stings, picture the invisible site beneath it. A quick plug, a cleanup crew, a living scaffold, a new surface, and a long after party of collagen are already getting to work. No single cell does the whole job. Platelets hand off to immune cells. Immune signals hand off to builders. Builders hand off to remodelers. The impressive part is not one star player. It is the coordination. Your body does not restore the past frame by frame. It builds the safest, useful version of the future from the materials at hand. That is why a tiny cut can become a quiet lesson in repair, trade-offs, and time. You will probably forget the cut before the remodel is finished, but the process keeps going after your attention moves on. Your skin is doing background maintenance with more teamwork than most group chats ever manage. Stop, clean, rebuild, strengthen. That is what your body is doing when a simple cut begins to heal. The phases overlap, the details are microscopic, and the result is a very human kind of engineering. A cut is not just a break in skin. It is a 4-stage repair project already in motion. Subscribe and like for more everyday mysteries drawn out one doodle at a time. Your body is already doing the invisible work. Keep the simple picture: temporary bridge, cleanup crew, new tissue, stronger scar, and keep serious wounds in the hands of real medical professionals. That tiny line on your finger has a story bigger than it looks. It begins with an alarm and ends with a useful patch. Thanks for watching Doodled. Subscribe and like for more curious questions drawn out, one doodle at a time.